Section 4.5 continues with proofs, okay? Except in these proofs, we are not stopping at two triangles being congruent, but we're going to take them a step further, okay? So we're going to use congruent triangles to prove something else. Now, let's talk about what we mean by this. All right. So the first thing is let's draw two congruent triangles, okay? So for example, all right. Say we have a triangle here. And this is triangle A, B, C. And we have a congruent triangle over here. Call it triangle D, E, F. Okay? And I tell you, or you know, that triangle A, B, C is congruent to triangle D, E, F. You know this, all right? This is known. So then the question is, what can you say from that? Well, we have this little phrase, right? Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. This acronym CPCTC, CPTCP, corresponding, oh, sorry, I didn't even know the acronym right. CPCTC. Corresponding parts of congruent triangles are congruent. Very important. So what does that mean from the picture above? Well, it means that our three sides in ABC are congruent to the three sides in DEF. And the three angles in ABC are congruent to the three angles in DEF. So we know 6 things, all right? We know 6 things. We know that segment AB is congruent to segment DE. I know that segment BC is congruent to segment EF. And I know that segment AC is congruent to segment DF. I also know that angle A is congruent to angle D. I know that angle B is congruent to angle E, and angle C is congruent to angle F. These 6 things I know just from this CPCTC idea. So once we prove triangles congruent, we can say that any of their 6 parts are also congruent. And this is what we're going to use in the following proofs. Alright, so let's take a look at a couple proofs on using CPCTC. Alright, example 1. Write a 2-column proof. Okay, and this will be the first one. And again, I'm going to pause it, copy it down, and then you do the same. Okay, so here is the proof with the picture. Down here I will create my 2 columns for my statements and my reasons. Okay, so I need you to understand that in order to prove this, we must first prove triangles congruent. Alright, so we need to make a note. First, we must prove that the triangle that has AB in it is congruent to the triangle that has CD in it. So we must prove that triangle ABD is congruent. So now I named triangle ABD in alphabetical order. Now you can use the correspondence from these side lengths. AB corresponds with CD. So ABD, so that's going to be triangle A corresponds with C, B with D, And now what's left for this triangle? CDB. We must first prove this. Once we prove this, then we can prove this using CP, CTC. Corresponding parts of congruent triangles are congruent. But we must first do much more before that. Okay? All right, so let's talk about what we're given. All right, first, parallel lines. 95% of the time, alternate interior angles. Second, they touch. Reflexive property. Okay? So I'm thinking maybe angle, and then the reflexive property for this side. So I'm thinking angle, something with an angle and 2 angles and a side. So let's write down our 3 ways: side, 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 angle, side, angle, side, angle, 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 side. There's our 4 ways. Okay, so let's start with the given. Segment AB is parallel to segment CD. Segment BC is parallel to segment DA. This was given to us. So let's look at the first pair. Let's mark this first. Okay, so we have some parallel sides, right? AB is parallel to CD, and BC is parallel to DA. Let's first work with AB and CD. I'm going to trace it using the red. AB and CD. And then I'm going to draw the transversal. So we need to be able to see the angles that are congruent, the alternate interior angles. If you look, this angle and that angle are going to be congruent. So we have to be able to write those down. Angle ABD is going to be congruent. Okay, so now angle ABD is going to be congruent. Use the correspondence. ABD is congruent to CDB. Angle CDB. CDB. There it is. Alternate interior angles theorem, or the fact that they're alternate interior angles. Now, I think we can do a similar thing with the other parallel lines. Let's get this going. All right, so BC. Let's do like BC is parallel to DA, and we have the transversal. So what are the angles involved here? Well, I think it's this one right here and this one up here. What is this? This is ADB, congruent to, again, use the correspondence, ADB, CBD, CBD. Again, they're alternate interior angles. Okay? So, angle, angle. Side, side, side gone. Side, angle, side gone. It's one of these two. So it's either going to be the side in between or some other side. Well, let's look at our picture. We haven't used the fact that they touch. BD is congruent to itself. Reflexive property. Right? BD is congruent to BD. Reflexive property. So, we know a side. It's the side in between the angles, so we can now say that the triangles are congruent. Triangle ABD is congruent to triangle CDB. And if we look, we found the side in between, so it's angle, side, angle, not angle, angle, side. But that is not what we wanted to prove. We now want to prove that AB, segment AB is congruent to segment CD. We'll look at the correspondence. We can use this idea of CP, CTC. corresponding parts of congruent triangles are congruent. CP, CTC. To say that segment AB is congruent to segment CD. So this is the proof. This is how it works. You prove the triangle is congruent, and then you use CP-CTC to say that one of its corresponding parts are also congruent. All right. All right, let's move on to the next proof. We'll do one more, I think. Okay, so here is our next proof. So again, please copy it down at your own leisure. But the given is that segment MP bisects angle LMN, and that segment LM is congruent to segment NM. And we need to prove that two other segments are congruent, segment LP and segment NP. All right, so let me do better. Down here we'll do our statements and our reasons. And before we start, we will game plan, right? MP bisects angle LMN, bisects two congruent parts, two congruent. MP bisects LMN. You should immediately do this. If it bisects the angle, it creates two congruent angles. Okay? Next, this segment LM is congruent to segment MN. This and M. This is a side. That's going to help us have one of the three parts. And then lastly, we look at the two triangles and they touch. Reflexive property. So the two triangles we have to prove congruent, right? So first we have to prove triangle, and let's work with see how it says LM first. So that's the triangle on the right. Let's call this LMP. We need to prove it congruent to triangle. So if it's LMP, then it's going to be triangle NMP. If we look at the parts, LM and M, it's corresponding. LP, NP, corresponding. We need to prove these two triangles congruent first by using side, 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 angle, side, angle, or angle, angle, side. Okay. Once we have proven the triangle is congruent, we can then use CP-CTC to prove that those parts, those sides, are congruent. All right. So the first thing we must do is write the given, right? So segment MP bisects angle LMN, and LM is congruent to NM. And this is going to be given to us as above. So what I will do is I will mark, right, LM congruent to NM. Maybe should have done that before. And I'll go ahead and put my S down here. There's my side, my first side. Next, we need to talk about this bisecting idea, right? MP is an angle bisector. This is an angle. So it splits the angle into two congruent angles. What are those two angles? Well, let's go with the triangle on the right first, okay? Angle LMP, this angle right here. Is congruent. Angle LMP is going to be congruent to angle NMP. And this is by the definition of an angle bisector. And there's one of our angles. So we throw away side, side, side. Right? So now the question is, where is the other thing, the other piece that we need going to come from? Oh, the reflexive property. Right? It's shared by both. Segment MP is congruent to itself by the reflexive property. So there is our third piece of information, our third S. So we throw out angle, side, angle. We throw out angle, angle, side. We know that we have to use side, angle, side. Side, angle, side. So we can now prove the triangle is congruent. we can now prove the triangle's congruent by using side angle side. So what are the two triangles? Well, we labeled them up here. Triangle LMP is congruent to triangle NMP. This is going to be by side angle side. So now that we know the triangles are congruent, we know that all 6 parts of one are congruent to all 6 parts of the other. So we can now use CP/CTC to say that segment LP is congruent to segment NP. So our fifth and final step, segment LP, is congruent to segment NP, and that is going to be by CP/CTC. Alright, so this is how all the proofs are going to go. They're just like the last 2 sections, but the last step is going to be this one more step using CP/CTC to prove that one of the parts of both triangles is congruent. Okay, so we'll work on this in class on Wednesday. Alright, thanks for watching.